In this video, we are going to talk about the whole process from specification to mass production. Is this what this video is going to be about, Zoran?
Yeah, exactly. So we are talking about how to get from the requirements, from the idea, and back to the manufacturable product that can be certified and legally sold.
Why
Because
why this topic is important? It's not like I draw my schematic and send PCB to manufacturing and ta-da, I can sell.
well, I've picked this topic for several reasons. One is to share with the colleagues who didn't have a chance to see the actual process, because many engineers, especially in big companies, they are doing one part of the process. In some cases, they are doing just the PCB layout or just the schematic or maybe just the requirements. In smaller companies, they have a chance to see more, but also sometimes, very often, they just see the schematics and the PCB design. And for people who want to build their own products, they need to understand the whole process. But also for the engineers, in order to be able to communicate better and collaborate better with other people on the team and who are working on the project, it's important to understand the big picture. So this is why it's an important topic.
Okay, so we can go to page 1 of your slides and let's start from here.
Okay, so yeah, we can go there. So now we already explained why this presentation. Yeah. So for the people who didn't have the chance to see the actual process, but what's the common misconception? I guess the clients come to you. You probably had these cases. Hey, Robert, we need you to design us a prototype, and then we will move that prototype into manufacturing, and then we will sell it and we'll make money, and it will be good for everyone, right? You're smiling. So
Yeah,
it is like that too. I've
actually very often I receive this kind of email like I have this idea, let's design this board and let's make money. Like I don't want to do manufacturing.
exactly. So, but the actual process looks slightly different under the hood. It's slightly more complex. So this is one example of the process. There are like variations of it. This is something that we are using in our company as we call it the 7 gates development process. So it goes through these phases to get the product from the requirements to the actual manufacturable and sellable product. But we'll talk about the misconceptions first. So the first misconception is like, oh, I just need somebody to design a PCB for me. They come to me and they have a Frankenstein's monster with the wires and it's connected to breadboard or some Arduino and say, yeah, we have a prototype. We just need to design a PCB and then we'll manufacture it. Well, there's a much more to it, and then they think I'm crazy when I tell them how the process looked like, and so they look me like a crazy guy who's just talking dark stories about failures and risks and so on. So I scare them a lot.
And maybe
And
they are thinking like you would like to make a lot of
I
money.
want to I want to make more money to charge them. Yes, it's so simple. You develop a prototype, you put to production, and then sell it. Why these guys telling me all these scary stories? So the other one is I'll just outsource it and we'll get the final product. I will just give it to these guys and then they will make it for me. And that's it. I don't have to do much. I'll just do the sales and distribution and that's it. Yeah, that's another misconception because people they have to be involved. The engineers must understand what needs to be done. We cannot just invent the product. We had these cases where, oh, just build me the temperature and humidity sensor and, just build me the sensor. Why are you so bothering us with so many questions? We just want a sensor, right? So, yeah, that is another one. And my favorite, we have a working prototype, so we just need a manufacturing partner. So they take their Frankenstein's monster with wires and breadboard and they go to the manufacturer. Can you help us produce the board for this? So then they forward it to us so that we do the design. Yeah, then we have a lot of explaining about that. So one good example, it was not a startup, it was a big company, and they are a mechanical company, and they wanted to develop a product that would be produced in 300,000 units per year. And they had some prototype and a life cycle of 10 years. So that's like 3 million units. And they assigned the project to a junior business development manager. Okay. And he came to me with the prototype. So we proposed the timelines. We were saying, no. This will be shorter. It's not going to, I have a friend at university. He told me it's easy. It's 2 months. So, so I asked, yeah, okay, you are developing mechanical products. So did you develop any product in 2 months, the mechanical one? How long does it usually take? Well, it takes much longer. So the conversation was very long, and we had the timeline, and he was still not happy with the time. He didn't believe me. So the other company gave them what he wants. They told him, yeah, 360 man hours. That's like 2 man months, hardware and firmware, and it's been more than 2 years since then. They're still not on the market. So
When you are talking about this,
mm,
actually, I have some stories on this
mhm,
topic because we have some open source projects. One of them is IMEX6Rex module. So it's a small module with processor and memories, and this module can be then used in baseboards, and people can create products. So this module, it is open source, but it's not open for business. But I know there are some companies who actually take the design and place it on their boards, and they think like, okay, now I have my own product, I can sell it, I can save money because no one has to design this middle board, or uh, or they actually take all the manufacturing data and they try to manufacture it by themselves and then use it, but they always end up with our manufacturing partner because they will actually find out that even just manufacturing the completely finished project is much more difficult than they imagine. Uh, so exactly what you are saying. People think it's just design the board and send it to production and receive 1,000 pieces. No, it's more complicated, and we are not even talking about how much money they need to have in stock, for example.
exactly. Yeah, that's a good point. And they also probably get technical questions from the manufacturing team, and there are some issues, and they need to be able to resolve them. And since they didn't do the design, and they don't know much about it. So
They ask
yes.
me questions like they even send us like pictures with the design integrated in their board. I'm like, it's not allowed. I
It's
know,
not.
but this doesn't work. Just tell me how I make it work. Okay, we
That's
can move to the
that's
next one.
interesting. Yeah. So another one is also
Compliance.
where
Yeah.
we will sort out the compliance in the end. Well, let's just do the design, and then once we finish the design, we will ship it to the lab, and they will give us the C mark so we can sell our product. This is very dangerous, actually, because if they don't think about the compliance up front, if they don't fulfill all the legal requirements, they may complete the whole development just finding out that it doesn't match, it's not compliant, it cannot be legally sold because it's not according to standards. And there are examples where the company did that, and in the end they find out that they have to go back and modify the design so that they can be compliant. But I'm not talking about just basic safety and DMC, but regulatory approvals standards for that specific industry, right? So it's much more complex than it looks like. So my favorite, will be faster if we skip so much testing and validation. The answer to this, it depends. Sometimes it can help if there are smart ways to take risks. If your product will be not exposed to certain environment, maybe it doesn't make sense to do all the tests. But in general, it is required to do the testing. So, or testing the product commercial with high strict requirements for the industrial equipment. So the approach has to be adjusted. But they think if we skip testing, it will be faster, but actually it will be more expensive because something will return from the field, it will fail, and they will have to find the root cause, and then they will have to fix it. They will have to do a redesign. So it's much more expensive in the end than doing it from the start.
Very often
Maybe you have some horror stories about that.
Not horror stories, but very often I point out exactly what you just said, because even when I was starting with hardware design, I built my first board and it was working on my table, and I was like, oh, like it's working, 5 minutes is working now, but then I learned, like, if it's working on your table, it doesn't mean it's a really good product, because it may crash, it may freeze, it may, if temperature is changing, it's going to do whatever, I don't know. So exactly what you are saying. And many people, if they never design any product, I think they just don't know that a lot of testing is really good for them, because then they will not have to refund their customers. They just need to be sure that the product what they are selling is really, really good. Otherwise, it's going to cost them a lot of money.
And the one that scares me the most is that this Facebook software mentality applied to hardware: move fast, break things. Right. Okay. So this is the invitation to the disaster party, having expensive recalls and failures. But there are clients that want to have this kind of approach. Just do it quickly, and we'll learn, and we'll give it to our users. They'll test it, and then they will give us backup. But in the end, when we look at it, when we analyze the time needed, it's not faster. It's actually slower, because you will do it later at the later phase. So it's just more expensive, and it will take more time.
And it will make some of the customers angry.
Angry, exactly.
This is how many software companies are developing their softwares.
Exactly.
I don't want to go into details.
So now we show the process that starts from the requirements, but actually what happens before the requirements? What is the magic that needs to be done? Where do requirements come from? Okay, so this is an interesting topic. It can be a workshop for itself, but it's important because the engineers are usually getting that from sales, from marketing team, from a customer. The requirements, the ideas are coming from somewhere, and they need to understand the problem. They need to understand the problem before applying the solution. So if we are building a product from scratch, they need to do the primary market research, which consists of the problem research and then the solution research. People are often confusing that, especially engineers. They think oh, I understand the problem. This is it. Now we'll do that. This is the solution, right? At the same, they are the natural problem solvers. They want to jump to that. When we had the workshop for design thinking, and there was an example of plastic farmhouse, and they were, oh, we did a similar project for that. This is it. We will just apply that to this, and that is the solution. No, it's just we need to understand the actual problem, the market needs before any development. Who are our customers? What do they want? What are their needs, expectations? What problems do they want to solve, and why? our solution solves their problem. It's important not to jump to the how at the beginning. So how comes later? This is just the problem definition and understanding the actual problem. And after that, then we have the solution research. So it's the lovely Frankenstein monsters building the bodge prototype with Arduino and wires and making a card box. So that is very important to do before committing to any significant development, because that can help us identify the technology risks. We can get feedback from the users, they can use it, we can see how they interact with it. So I have an example where we did a project for, it's a class 1 project, medical, for accelerated recovery of athletes after injury. And we did a proof of concept, basically, of Frankenstein.
Yeah, that's how I call it, proof of concept or proof of
concept.
idea.
So we stripped off the Omron blood pressure monitor to get the valves, cup, the enclosure, put inside the development kit, glued with the plastic glue wires. And then on the outside, it had a nice mechanical design. The mechanical design partner did a good job on that. So they were able to give it to the customer, to do the presentation to the investors, to get the feedback how they are actually using it. And then we moved to the actual requirements after they validated all the hypotheses, the market, how the users interact, what is important. So at that point, they were able to validate the hypothesis and start making the requirements. So after building the Frankenstein monster, right?
Very often I do it also because sometimes you don't even know if it's going to work or if it's going to be exactly what you are expecting. Sometimes it just doesn't work.
Exactly. The technology applied to that problem maybe doesn't solve it. So you have to look for a different approach.
Or maybe do different idea.
Different idea, yeah. So this is this phase, it's important to validate this hypothesis. Very often do the feasibility study. That's not just a technical feasibility study. Yeah, technically it makes sense to do it, but we also did feasibility studies in an economical way. Is there a return on investment if the client does that project because they have a certain volume? They are currently buying off-the-shelf solution. If they develop, it will cost this amount of money. They need 3,000 units. Does it make sense to invest in that? So I know one example where the client asked us to develop off-the-shelf, to develop custom solution for them, and they were buying industrial PC and the gateway, so it costed them 1,300 pounds each system, and they needed more than 3,000 systems. So they wanted to develop a custom gateway, a custom controller solution, and to replace this one. So we said, okay, let's see what's available off the shelf. So we found them, we did the analysis, doing some draft schematics, some research, how much would the BOM cost, how much would the development cost, the certification, and so on, and the timelines, of course. So we presented them, okay, this is the custom design, this is the off-the-shelf solution. We found some off-the-shelf solution for 240 pounds at the time, and we were able to port the software that they had. So they save basically 1,000 pounds for each system. On 3,000 systems, you get the math, right? So the savings are in millions, and basically the whole investment was around 20,000. So invested 20,000 to get a few millions back. It's not a bad business, right?
This is actually, I've seen this a couple of times, that sometimes companies, they have some kind of solution, and based on this solution, they are able to expand their market because maybe they will get new client, which will secure much bigger contract, and then they would like to optimize.
Mhm.
Yeah, exactly. Okay, we can move to the next one. So first is the
Yeah, the requirements. One very convenient format is called FEARS. So it's functional, electrical, appearance, reliability, and safety. So this is all that is needs to be covered to have a uh, full requirement. And there are two schools, like standard engineering answers. Do we do it brief or detailed? It depends. So sometimes it's good to do a brief, but covering all the main aspects. So you don't want to make a requirements and then go to the validation phase and figure out, oh, my clients actually don't want a Bluetooth, they want a LoRa network or a Wi-Fi. So I have to go back and modify the whole design, going back several phases. So it's important to cover the main aspects, especially in consumer products. This is very often deliver the 20% of the functionality that gives 80% of the value to the user. And then the user can give more information about what they want from the features. But the main functionality should not be completely missed so that we have to go back and think. While on the industrial, you don't have this kind of luxury. There are many details that has to be taught upfront, and the requirement must be very detailed.
I would like to point out. I think what is really hard for engineers, if these requirements keep changing even during design process, you are like finishing PCB layout and someone would like to change something and I'm like, no, I'm
Oh,
not going. It's going to take more time than drawing it again.
yeah, exactly. That can be the reason that maybe they haven't taught everything, um, or they didn't put enough effort into the requirements. So that can be the reason. Or
You
no.
know, I have solution for this, and what worked for me was uh, very often when I draw schematic, drawing schematic is not very difficult. I can redraw it. There's no problem. Problem starts when doing PCB layout. So before moving to PCB layout, I really would like to have the requirements or specification completely finished. And when doing schematic, and there are some areas which have not been decided yet, I just very often try to implement support for everything what people would like to have there. And then when I start doing layout, I will say, okay, we are space limited. So now tell me which of these features we are going to remove. And that's how I
Mhm.
work. And this speeds up process a lot because otherwise, if I wasn't sure, I had to ask someone, okay, are we going to add this temperature sensor? And they were like, okay, I will ask the client. They will ask client, are we going to add or remove this temperature sensor? And then client, after 1 week, answered, and it took ages.
So
Making these
it's
specification requirements took 3 months, and then our leader was like, okay, we have the specification now in 1 month. Can we have PCB? Like, you did specification 3 months.
Yeah, that's a good approach to have that in the design already, and then remove what they don't need. And very often there is a luxury to keep it, and
Yeah,
use the design variants. So just leave the extra components as footprints. They don't cost anything if they are not soldered, and they just consume the PCB space, but the board will be the same shape anyway.
yeah,
So there are no extra costs, but maybe that enables later on some upgrades. So that is a good approach. Yeah. We also do that if we don't know what will be. So just
put it
set
there.
it in the design and then manage it through the design variants. Yeah.
Yeah,
Good, good point. I like that. So here is an example of the BLE temperature logger. The examples from the categories like functional, electrical, appearance, and reliability. So it's important to think about even a potential misuse. So we see that the enclosure shall resist mechanical damage from drops of up to 1.5 meters of concrete. So for example, an operator on a production line is putting a sticker or trying to test it and then it drops accidentally, so you don't want it as a failed product, or a technician in the field is installing that and the device drops from his hands accidentally while he's looking for a screwdriver or something. So there are misuses and potential cases that this should be considered from the start, like the environment, the electrical, the security, the functionality. So all these aspects need to be considered to have the proper requirements. And the more you do upfront, the less work in the end and less changes. Unfortunately, the only constant is that it will change.
Why did you use this ID like F1 or A1?
So F wanted to have, usually it would be a functional and then the list of functional electrical, but I could not put it in the slide. So it has F1, A1. F indicates functional, E indicates like electrical, but also when we will talk about it in the phase 6, right? So validating the stuff. So we have a requirement E1 that is linked to the test case TE1, for example, so that we can validate the requirements against the actual product that has been made. So there is a reference. This can be A158, I don't know, because the requirements are usually very long document, even for a simple product.
So basically what you are saying here, we should have a look on the finished product from different views. Like I'm looking at the product as an electrical engineer. I'm looking at a product as someone who is going to use it or mount it or test it or this kind of stuff.
Yeah, if we go back to the fears, so it means the functional, what functions are there for the user, what are the use cases, the electrical, is it going to be connected on 220 volts or 24 volts? What would be the voltage range, the frequency, the environmental, is it going to work indoor or outdoor? What would be the temperature that the device will operate, the appearance, the aesthetical. My favorite requirement when the clients, I want it to have a sexy design, right? And that's very often so.
That's enough, yeah.
That's enough. Yes, yeah. I
It
want
has
to have
to
a
look beautiful.
Sexy design, not beautiful. Beautiful is not good enough. So sexy. So, and
Flashing LED.
Flashing LED. One interesting story. We have a client, we're working together for more than 10 years now. And the requirement was, I want to have an apple green LED. Okay, apple green LED. So we took many LEDs, comparing the wavelengths, the shapes, putting it inside the enclosure, seeing how it reflects, and then making photos and videos and sending to him to verify. So that took like 3 weeks to pick an LED. And if you ask somebody, what would be the time required to select an LED for a project? You wouldn't say 3 weeks for sure, right? But actually taking all this information about the available components, ordering them, putting them on the board inside the enclosure, testing, this all takes time. So just to pick the right LED color to make the design look sexy.
Okay, we can move to the next because time is flying.
Yeah, time is flying. Yeah. So requirements are boring. How do I even start? Brace yourself because boring slides are coming. So the first thing, get a regulatory consultant. They can tell you which standards are applicable for this type of product, and they can also save you a lot of money if they make a good strategy how to certify a product. So for some products, the costs can be high, even few €100,000. And for medical products, my colleague was working on development on infant incubator. and the compliance costs for that are millions. So if you have a regulatory consultant, he can make a good strategy and he can save you a good money. So a project that we worked, one example, it costed 285,000 pounds, the compliance, right? And
I know. I also, yeah, if you have to do like FCC or something, it's going
multiple
to
markets,
wireless.
Yeah,
Multiple
exactly.
markets, exactly what you said. Actually, I made a video, a very good video on this topic. Right now, it has not been published yet, but maybe when people will be watching, it will be already published. So I will put the.
So you can link it here. That's
I will
good.
link it here, and it's about compliance, like EMC, FCC testing. Very good video. So I really recommend to watch it, and it's exactly with someone who is exactly the consultant in this area, and he exactly recommended what you just said.
Okay, that's good. It seems like I know what I'm like.
Yeah, because maybe for some very simple products, I don't know, maybe people think we really don't need it. But if
Yeah.
you go into some areas, even like toys, or it's going to, or as you mentioned, medical, it's going to be very, very complicated.
Yeah. So and then when you have the consultant, so it's important to determine what is needed for the compliance from start, right? So that it doesn't get one way to do that also for maybe some simple products, as you said, you can ask for quotes from labs, but what will happen? You ask 3 labs and they will give you 3 different quotes with different set of tests and the product will be in a different category. So one example, we asked, our client asked 2 labs. One gave 17,000 euros, the other one gave 3,000. How do you compare? And the one with 3,000 just said EMC testing, safety testing. Okay, so we had to enter into a discussion with them. Okay, give us a list of tests that are included. What is in the quote over there? So it has to be specified in detail when asking quotes from the lab. Just get as much as details so that it's not like, oh, this was not included. Sorry, yeah, but it's not going to be 3,000. It's going to be 33,000. Or another project, the same product, 2 different quotes from 2 labs, completely different. They categorized it in a completely different category of the product and different test supplies and different test levels. So it's very important to know the compliance requirements up front and then to verify it with the lab. So yeah, I've already mentioned that which standards are applicable to the product. As we have an example of the temperature logger. If we look at the food industry, so a temperature logger for food tracking in trucks that are transporting food and they have temperature logger. So there are sets of standards that are applicable to this product, and include those requirements from standards into your requirements. Now we are coming to the easy part, like easy understanding the user, the use cases, the wrong use cases, malicious use cases. Somebody will try to maybe break it with a screwdriver, or maybe they will do something stupid with it. So it's important to think about that. And what are the critical to quality features of the product? Beside, and the other is determine the operating environment and so on. So yeah, I've said that the slide will be slightly long and boring. So if I say it up front, then it's forgiven. But the good thing is that you can use ChatGPT as a initial inspiration, and he can do a lot of work, a lot of boring work for you at the beginning. Not to mention, analyze the security. Now, very important, the new radio equipment directive requires cybersecurity as for compliance. So this is. So what happens if we ask? How do we ask a ChatGPT prompt? So this is
curious.
yeah. So we can the people can play with it. They will maybe get the different answers, but this is actually a very good start. It makes sense. I've checked, but still, it's not a replacement for a regulatory consultant. This is good for the people. So we have clients like they don't know where to start, or they just ask us for help. Where do we look? How do we start? What do we need for compliance? So putting this prompt and describing the product is in as much as detail as possible will give you a list of requirements, and it can, if you go into deeper questions, it can make you the whole test plan, which tests are needed for your product actually, and then you can verify that with the lab and with the regulatory consultant and so on.
We talked actually about this in the other video, and I think what he mentioned, the one of the biggest confusions with AI is that AI may not know the latest stuff because the latest stuff is not mentioned as often as maybe something what was old. So it can come up with some old answers, which may not be very correct. But exactly as you said, if you don't know where to start, you can. But I always keep saying, even when I show AI or ChatGPT to my parents, like, don't trust anything what it is saying.
Exactly.
Always
So yeah,
verify.
this is a good point. This is a good point. You'll see it in the next slide where I've put for compliance. Yeah, I've mixed. This was the prompt for the requirements, and I was talking about the compliance. But for the compliance, yes, it can give the old data. And for example, when I was preparing example for this, it took me several iterations, and
Mm-hmm.
he wasn't giving me the latest radio equipment directive.
Yeah.
So I was specific in saying me check if cybersecurity and the latest radio
Yeah.
equipment directive is applicable to this type of product. So we'll see that when we come
Mm-hmm.
to that.
Okay.
Yes, so we can conclude that the chat GPT
Yeah, you have it. You have it in slide.
can give false information for sure, and we have to be careful, and it is not a replacement for regulatory consultant. But remember to thank ChatGPT. You never know when the judgment day comes. He may say, "Oh, you were nice to me."
It looks like we are making fun from AI, but the other day, actually, I this is a little bit off topic, but so I opened Microsoft Word because I had to fill up a form from a client, and half of the form was in French, half was in English, but not everything was translated because some of the answers were already pre-filled in French. And the Copilot appeared on the right side of the Microsoft Word, and I'm like, let's try it. It's there, so let's try it. So I asked, like, translate this document, and it just listed all what was in English, and I was like, but translate what is in French. Again, it listed again exactly same thing. And I was like, are you? And Copilot was like, I'm not going to talk to you anymore.
Mhm.
I'm ending this chat. And I'm like, what?
Oh, okay.
So who knows where we are going? Maybe this picture.
Robert, I would be worried.
I'm now.
Remember. Oh, be nice to the machine.
Let's go
You
next.
never know. Okay, yeah. So now a
But I
few
was
tips for.
really like, I told you twice, like, translate it, and it didn't translate it. I was like, I'm wasting my time with you.
Unfortunately, it happens. So the few tips for the requirements. We've mentioned that it's very difficult, but very often people don't look at the requirements as investment. They see it as like costs or something boring, or the documentation. It's like, oh, I have to do that. I don't want to pay for the requirements to get a couple of papers. It's like, just do me the design. Don't want to do that. So it's important to invest time into creating the requirements. It's also important to invest time in reviewing them, because this is the least expensive. Finding a mistake or finding the issue in the requirements costs much less than finding it later in later phases. And what is also important is to have the team aligned and have the same understanding of the requirements. Back in the past, in NASA, there was a gated development approach where they have a requirements department, then they throw it over the fence to the design department, and then the design department team does the design, and then they throw it to the test team, and then the test team does the tests. So the design team had a wrong understanding of the requirements, and the test team had a completely different understanding of the requirements and the design. So it hasn't been designed as it is specified, and also the tests are completely missing the point because they also have the different understanding. And now we have agile methodology. So we have refinement sessions before actually implementing the design. So Scrum says that you need everybody aligned. So if you need a mechanical engineer, electronics engineer, firmware engineer, even manufacturing, they all should be aligned on the requirements before actually implementing that. So this is very important, how to make the team aligned around the requirements, and how to make because everybody will think something. They will think about the edge cases. They will figure out some potential risks. So four heads are smarter than one, and yeah, it's important that they work as a team to refine the requirements in that way.
This is
And
actually one of the, again, when I was talking to the guy about the testings, or about the EMC and FCC, uh, and when we are talking about AI, making or suggesting all these regulatories and what to test and how to test, then he exactly mentioned this, what you just said, like you may try to explain what you are designing, but AI may understand it a little bit differently, and it will give you different answer because you don't understand each other. You would need to be very, very specific. Maybe you missed one very important point and you didn't include it in your request, and it would completely change the answer.
yeah, exactly. For example, the type of wireless technology, I want to make a wireless communicator device. The ChatGPT can make assumptions about the technology
Yes,
and the compliance. And if you would say, I want to make it a mobile with the GSM communicator device, that will be a completely different regulatory set that it will give compared to the first inquiry. So it has to be very specific and giving him as much as more
yeah.
details as possible.
And I guess this is exactly what you just said. There has to be this understanding also between all the other teams.
And now we have to understand it, also make an understanding with an AI. I don't,
Okay,
it
let's
doesn't seem
let's
to it's not getting easier.
let's move to the next one because
Yeah.
I'm really worried. I'm really worried. We will not have time
Yeah,
to
we are
finish it.
already talking for an hour. Oh, geez.
I
So yes,
yeah,
important to prioritize, make how these requirements impact the business case, cost benefit analysis. Does it make sense to invest 6 months in developing some feature? What is the business value for the user? And plan for change, because it will change. It's not possible to see the whole project up front, maybe at half the way the project. So yes, product value equation, the value, performance and costs. It is written on the slide, so I'll just accelerate it. Now we are moving to the phase 2, actually, which is high-level design, and we spoke about the product value previously. So at this phase, by this phase, when this phase is finished, we will actually set the 80% of the product's value, because we will define all the main features, the requirements, we will define the main components, and later on, as the process moves, we have less and less ability to influence the product value over development cycle. So what in this phase, it's critical to pick the right development strategy, because it's not a one size fits all. It has to be optimized for the target production volume. I will not develop the product the same way if the production volume will be 1,000 or if it will be 100,000 per year. Okay, so there are trade-offs, and the strategy has to be adjusted according to that. We cannot do the same thing for every product. But how to decide what is important for our product? Is it the cost, performance, or time to market? So if you ask a client, he will say, everything is important for me. I want it to be low cost. I want to have a good product performance, and I want to have it fast on the market. So yeah, unfortunately, you can pick only two of them. Do you want the good and cheap? Won't be fast and cheap won't be good. So find the sweet spot for your product. So that's why hardware is not so easy. Need to make trade-offs. So examples, it's not the same if we are developing consumer products or industrial specialized products. With consumer products, it's time to market over perfection. It's about who's going to launch it first. It's important not to have a product exploding, but having some minor issues that can be fixed over the air updates, adding new features to the users. While if we look at the industrial product, it's all about reliability, long life cycle, availability of the components for 10 to 15 years. And in many cases, lack of OTA or the update would be very expensive, because the technician has to go to the field and they have to plug a USB or a memory card to do the update. Different aspects, also production volume in consumer, it's higher, so the development costs are absorbed. So if you look at the development costs absorbed per unit produced, they are absorbed over the high volume. And if you look at the industrial products with the lower volume, the development costs affect more on the final product price. So this is a trade-off, how to approach the strategy in the development.
I'm going to interrupt you less so we can go faster.
Okay, good. Now, this is what we are doing in the high-level design, is getting the idea about the possible shapes, the size, collaborating with the mechanical engineer on their initial designs and giving them the constraints, because if you ask a client, they will give you 2 centimeters by 2 centimeters and you put 6 wireless technologies inside. So it happens like that, but you need to give them some constraints. You need to test what is possible. So doing this high-level design and working with the mechanical design engineer on that one. The architecture is also the part of the high-level design, and selecting all the main components and critical components. So what's the issue for engineers often is that they don't talk to people. They are introverts. So but it requires a lot of talking. Talk to the manufacturer, talk to the chip supplier, check if the components will be available in the next 10, 15 years. How long will your product last? It's important because you don't want your client to do the redesign after 2 years, because the component is end of life and they still need to produce it for another 8 years. So it's important to think about that. And also the suitability. You can send your architecture to the chip vendor and they will say if this component is suitable for this purpose. Very often, if if the concept is innovative, we ask them, does it make sense to do it this way? Can you confirm? Do you maybe have a better component that will do a better job? What is on your roadmap? Because this product will be here for 10, 15 years. Is there something new that you are working on that will be out next year and we can start working on that? So this is critical at this phase because the decisions will be very difficult to fix later on. If something wrong is decided at the beginning, then the changes will be difficult and expensive in the end.
I know, for example, sometimes we even buy different reference boards from with completely different chips, like maybe let's say NXP or TI or something else, and you compare the performance if it's because one of these may be much better to the product what you are developing than the two others.
Exactly. And also, there are so many chips. How to select which one is the best for your application?
Even from same
Engineer,
manufacturer.
even from same manufacturer. Yes, that's one way is to pick the one that you have experience, and do that. That's a low risk. It's fastest, but maybe it's not optimized if if you are producing 100,000 units per year. Maybe it's not the best in terms of cost and performance. So how do you decide? So using the component selection matrix is one way. So deciding, does it meet the criteria? Is it better than criteria? What is the low importance, high importance? And then scoring that. So this is one way to evaluate all the parameters in a systematic way and make the decision rather than the gut feeling. Oh, I know this chip. I played with ESP32 at the university. So we will now base the whole product portfolio based on that because I'm familiar with that one. Yeah. I don't
Yeah.
say it's the wrong one, but maybe.
But I think many people actually work this way, especially when they are starting with something. For example, for me, I don't really care what chip manufacturer I would be using. I'm looking for the chip which is the best for the project because I was already working with many of them, and I know it's almost same almost every single time. You will figure it out somehow how to work with it. But I know people who don't have enough experience, they will try to prefer to work with the things what they used to work with.
Exactly. And this is like also a common misconception. Oh yeah, we will do it now that way, and then once we go to production, we will optimize the cost later, right? So what you've mentioned here now is you've worked with different chips and it doesn't matter. Maybe at the beginning, if you're taking a new chip, there is a learning curve and you need to invest initial time. But for example, if you invest 1 month of work for a chip that is €1 lower cost and you have a volume of 150,000 units, that is not a bad month of investment, right? You've saved 150,000 across the product lifetime. So it's not just about picking the one that you know, but picking the one that is right for the project and having in mind this is not a sprint, it's a marathon. Actually, the product has its own life cycle. So the cost impact, also need to make sure that it doesn't break the business model. Every dollar or euro we add to the bill of material, it adds to 4 or 5 when it gets to the final buyer, actually. So if we over-engineer things, that can make the whole business model completely not viable, or the product is no longer competitive because the competitor is offering the same performance at lower cost, and we over-engineered our product. We added 5 more euros to that, and it's no longer competitive in that sense. So the other important thing is what people do. They put chips in the design and then they complain, oh yeah, this is too expensive. Well, when talking to manufacturer, they told me, yeah, now you bought our chips at this price and you are producing, so we consider that you were happy with the price. Okay, so it's very difficult to negotiate it. But before actually putting them into the design, you can say, yeah, we are evaluating these chips and from you and the chips from other manufacturer, and we like your chip, but it's much expensive. It spoils our business case. Can you check with your team? Is there something we can do about that? Very often you would be surprised what they
I
can do.
never tried this.
Yeah. Sometimes it's strategic for them. Sometimes it's strategic for them to give you, because if it is maybe a new system on a module, and if they give you at a lower price, they will get a manufacturing volume that will reduce
Mm-hmm.
their manufacturing
Mm-hmm.
costs, so they can give you the lower price, right? And it's strategic for them also. So we were able to get some cost that, you see one thing at the chip manufacturer and you get the other one completely because the project is maybe strategically important for them.
Mm-hmm.
So this is the time to negotiate. Now we had a similar case where one of our clients got acquired by a big company, and the big company has its own product portfolio. So they are using chip from one manufacturer, and they are doing bulk buying, to use the component across the product portfolio. And our client is now part of that group, and we are using a different chip manufacturer. So we told, look, they are asking us if we can move to their platform. Could you help us get a better price, or we have to move to the other chip vendor? We will port the firmware, and
Yeah,
they
I
did the
think
magic.
this is same with even like with the design software. If you are using Cadence and you go and say Altium, like, I would move to Altium, but you are too expensive. They may be like, okay, if you move to Altium, we can give you a special discount. I
Ah,
think it works all the way.
totally. Yeah, good. This is like a strategic. For us, it doesn't. It's a pain to move to the new platform, and for them, they will lose us as a customer.
Yeah.
So this is the real case. It's not like that we are using some predatory
Yeah.
tactics.
I'm also talking about real cases
Yeah,
because
yeah.
many times people they do this really.
And the other thing is just always have in mind engineering cost versus BOM cost. So we have colleagues like they are thinking about how to optimize the bill of material. So they go and they spend time looking for that, but it doesn't make sense because their work is more expensive than the savings they will make with optimizing the bill of material. So if the product is low volume, like this specific case was like few hundred units per year, and they went try to optimize it, it doesn't make sense. It didn't make sense. So it's important to, or maybe time to market is the priority. It doesn't make sense to spend time at that point. So it always need to have in mind what is the priority. Is it time to market, or the production volume is low, or we need to optimize it. So it's a trade-off. Yeah, hardware is hard. No. Oh, so the high-level design. Yeah, I'll put some couple of things here. So it's very critical to determine the power consumption even at this early stage. I saw a real example, a company, they went with the product to production, basically, and the product works. The only issue is that they have a requirement that the battery lasts 24 hours and their product can last for 6 hours only.
Mm-hmm.
So and now they are trying to optimize it. So their own engineering team now spend months, and they have to go back and rework everything, which is costing money to pay salaries to all those people, and there is also missed revenue opportunity of several months not being in the market because they didn't consider it at the beginning. or they thought, yeah, never mind, we will optimize it later on once we come close to production. So it doesn't work that way. Yeah. What comes as a fast now, it's maybe later a very expensive mistake or an exercise. And also the early identification of the technical risk, as you said, getting several development kits, testing them, see how it works, just don't making assumptions about the performance. It's always best to test them. If you have an idea for a circuit, try it out on a breadboard before it actually goes to the design. And the requirements. It would be great if you can finalize the requirements at this phase.
We already mentioned this.
Yes. So at least the critical ones that will not cause everything to go back.
Yeah, let's change the main processor.
Let's change the main processor. Yeah. Also requirements if you want to move to the detailed design, starting the work on the schematics and PCB design, it would be great to already have the compliance requirements and the compliance test plan so that you know what your schematics and what your PCB will be tested against. So that I now did the design and then later on I will send it to the lab to get a C mark. So know the requirements, the compliance requirements before actually moving to the design, to detailed design. And how do we? No, we'll just ask ChatGPT. So I prepared one prompt to make the people who don't know where to start and what is actually required from the product. It's still not a replacement for a regulatory consultant, but they can use it to start. And as you mentioned the point, it may give you some old information. That's why I specifically asked him about the latest radio equipment directive here, because he was giving me all the outdated information. Yeah. So who is curious, he can put this into ChatGPT and see what happens. It will not be a simple answer, that's for sure. And yeah, so this is a painful topic, but engineers know things can go wrong, and things will go wrong, but we can do stuff to mitigate those risks. And how to do that? Start by asking what is new. Is it a new colleague, a new supplier, a new chip, a new technology, a new framework, a new version of the stack, a new solution that needs to be developed? Usually what is new is a risk because we don't know. Yeah. So this is where the risks can come. What are the dependencies? Do we depend on something or somebody else? Do we depend on the external supplier to deliver us components or to deliver us the PCB or to solder the board? What are the points of failure? So asking those questions can make the difference between failure and success. And the engineers keep that in their heads and it keeps them awake at night. Oh, what if this goes wrong? Yeah, but what happens if we put those risks from the head to the paper and try to make the mitigation actions actually? But hardware product. So we're not just talking about technical risks, hardware, firmware, integration, testing, validation. So those are all the risks that are, let's say, engineers are familiar, but there are also supply chain risks. Everybody remember the chip shortage. So on Friday, you have 10,000 chips at DigiKey. On Monday, they are gone. So you have to change.
For 2 years, or I don't know how long it took.
Yes, it took like 2 years. So supply chain risks. So you don't want to produce a product with 10 million units per year and depend on a single chip vendor during chip shortage, right? So the client had a strategy to to do the two designs, one with the Nordic and one with the STM, and single firmware, so based on the Zephyr, so that it can be ported from one platform to the other, so that they don't depend so on a single chip supplier. Or also more and more when we're doing the design, we have requests to do even more design with generic components that are available from different manufacturers. It makes the design more complex, but it actually de-risks them even in the next 10, 15 years, that if the chip shortage happens, they can have this
This is what
generic
I do. I
components.
learned the hard way.
Yeah.
Like I remember once I had a project and I found chip exactly what was the chip was exactly doing what I needed. So I got the sample uh, and everything was working perfectly fine. And then I send like request, okay, we need more chips, and the company was poof.
Yeah, that's an unfortunate
We
story.
had to
Yes.
redesign the board. So since then, I was like, if it's not in DigiKey, I'm not going to buy it.
Mm. Yeah, so exactly. The many risks, not just the technical, also market and business risks. You are too late with the product, or the product becomes too expensive, or the client and requirement. The client keeps changing the requirements. That's a risk, because the project will never end
Yeah.
actually if he's changing it all the time. And that influences the cost and the budget. So we can talk about it forever. So now we are moving to the detailed and the real work. Actually, is the actual schematics and the PCB design. That's what the engineering is all about. Right. Now, so unfortunately, I have to disappoint here. We will not talk much about it. It's also your job. You are doing great trainings and courses on that. So
Thank you.
I don't want to step onto that. I cannot. I'm not competitive in that area. Right? So we'll just touch it on a high level. So before doing the detailed engineering, we've already mentioned. So finalize your compliance test plan, finalize the requirements, the critical parts, and also the risk assessment. Do this in every phase, not just. I won't repeat this so that I don't sound like a parrot, but do this in every phase. Do the risk assessment, put it on the paper. There are many risk register document examples online, so that can be an easy start. Even ChatGPT can help with risks. If it is a new project, it can really give some useful insights. Now for the schematics, we talked about already a few times how to simulate and test things on the breadboard before putting it inside the design. What is critical here, and engineers tend to they do the calculations in the paper somewhere in their notebook, but actually those calculations are required for the technical file for compliance. So save them, have them in a document so that it can be placed in the technical file in the end. It's also good practice to put calculated values in the design. If we know the 5 voltage is expected at this point, just put it in the schematic as a note. If we expect a certain current going through certain area of the circuit, just document that so that when the board is being tested or when somebody is doing the review, they can check the calculation, they can
I do
check if
that.
it
Yeah,
makes sense.
exactly.
Yeah, yeah. Also, talk. Engineering work is a lot about talking. It's not about sitting in the basement and drawing schematics in the dark and coding. So you have to talk with your firmware colleagues, ask them what they need for debugging, for troubleshooting, how, do they need extra UART pin or LED blinking, how they will connect test points. It's important to think about the manufacturing test strategy, how this product will actually be tested in production, so that you don't do we'll just do another iteration because we forgot test points, so it cannot be tested in production. We see this very often, not
Hmm.
from us.
I
But
I would like to mention my story on this.
mhm.
someone sent me schematic and or even board. I think it was like finished board, and I'm like, how you are going to program it? And because there are people who only think about the function. So they put there all the components, everything to meet the functional specification, but they completely forget the steps. Like what I always say, like imagine you received your board from production. So what are going to be the steps to bring it on? Like you need to connect power, you need to connect JTAG or programmer, program the chip, and then you will be like, oh, where is my JTAG connector?
Exactly. Or also that this board will be used by the firmware engineers, and they will unplug it, plug it. They will do that for many times. They will connect wires, disconnect. So this board has to survive all that torture during development. So otherwise you'll have a lot of board die during the firmware development process, and they will not know if the board is failing or the firmware is failing. What's wrong? What did I do wrong? So this all has to be like adding ESD protection on where the firmware guy will be testing and where he will connect his tools. And of course, the design review. So, and using checklists, we also have checklists for the schematic and checklists for like hardware review by a firmware engineer checklist. So, what the firmware engineer needs to check when he's looking for the schematic, what is needed for him actually. And now that we've covered the whole wisdom of the schematics, now we are going to the PCB design, right? So maybe you can shed some light on this. So what is the best way to understand the complexity up front? So how complex will be the board that we are designing? In which environment it is going to work? And so, have some horror story maybe about that.
Not really, but I know, for example, once we worked with a company which was doing PCB layout, and then I asked the guy who was doing the layout, like, "Oh, where did you study? How long you have been doing this?" And he was like, "Oh, I was without job, and they told me like everything what I need to do is just connect this pin with this one." And I'm like, okay.
Yes. Yes. So I know a PCB manufacturer that they have like a team of people who are doing the layout for customers, and some of them were construction engineers. So they were not electrical engineers. And so also when we sent some of our people to the IPC training for the PCB design, he said, there are only 2 or 3 of us who are actually the electronics engineers. The ones that they are completely from different areas, like a mechanical engineer doing a PCB layout, and the company sent him over there because they think it's just doing the connecting the dots and
Connecting the
doing the
pins,
layout.
yeah.
So it is, yeah, it happens.
So I would like to just confirm it's not about only connecting the pins.
Definitely not. Yeah. So the defects, design for excellence. When thinking about the PCB design, it's important to think about how the board will be manufactured, how it's going to be tested in production. Is it optimized for cost? Is it able to assemble it? We don't want a product that takes half an hour to assemble on a production line. It's not convenient. And also design for procurement. We mentioned already the chip availability, so it doesn't make sense to design a product that we cannot procure components for that. So all these aspects, they have to be taken into consideration in the design phase, not when we move it to production. Like that's too late already. So we have to think about that early. And now the wisdom about the PCB design, one mistake that is very frequent is to think about the manufacturing. Once the design is finished, they will finish the design and we will send it to the manufacturer. That's wrong. So talk to the manufacturer early
Why
the
it's wrong? Why it's wrong? Tell people.
because maybe they cannot produce this kind of setup, or
Exactly.
maybe they don't have this technical capability to assemble the chip one on top of each other, or they cannot have this proximity of the two components in between, or the panel doesn't make sense, so it's important that they cannot do that size of panel. So they have the serious one. They have the technical capabilities sheet, so we can ask them upfront about their standard stack up, the assembly house, what they can assemble, what are the limitations. And it's good practice not to use advanced stuff just to show off in front of the boss. Keep it simple, do the basic stuff, the basic solution. If you need to use some advanced techniques, check with the manufacturer if they can actually make it, or they will give you an advice how to do that. Like following the standards is assumed, and getting the design review and from the peer or external design review, or if somebody can do EMC design review before actually going to the lab and thinking about that upfront. So now I remember the story. One of our clients was launching a product, and they did the design in-house, and they, in order to launch it, the product has to be certified, because they are already, their CEO needs to sign the declaration of conformity, but they haven't done the EMC tests, so they don't know if it is a risk for him to sign it, because there will be a time where before they finish the compliance and testing, and by the time that they are actually selling it. So we had to do a design review and the risk assessment, the DFMEA for EMC, actually to see for each test what is the risk that the product fails the testing. So you can hire somebody external to do the EMC design review, and maybe somebody in the team knows that, or ask a colleague. So it's always a good practice that somebody else looks at the design. And the checklist. There are so many stupid mistakes that can be prevented by using checklists.
Not only in PCB.
Not only in PCB, yes. And of course, the 3D integration, because the board has to fit inside the enclosure. I've heard so many times, we did the good job on the PCB design. Everything works well. It's just that we've missed the position of the connector, so we cannot fit inside the enclosure now.
Or there are no mounting holes.
Or there are
I've seen
no mounting holes. Yeah, exactly. Or the mounting holes are next to the antenna area, the PCB printed antenna, so the screws are in there. So mechanical error is equal electrical error. If your
even worse,
PCB,
even worse.
Okay. Yeah, you can patch with the wire if there is an electrical error. I don't know how you can patch this. Drill a hole inside the enclosure. So mechanical error is worse than electrical error. We can conclude that. So a couple of techniques is just 3D print it, use paper models for flex. Sometimes there is a very complex bending of the flex that has to be checked, and also the length. So this all can be checked and mitigated by doing simple 3D models and 3D printed. Also for the aesthetics, you don't want to put, so you have two connectors next to each other, and then it turns out you cannot plug them at the same time.
I exactly wanted to say this.
I had laptop like this, so I cannot use two USB sticks at the same time. It doesn't make sense. Or I cannot use a USB stick and a VGA connector at the same time. So that's important to think about it as a user and get it in the hands
this is exactly the reason why I do 3D printing or paper models, because when we are designing PCB, we only see half part. We don't see the second part, which is going to be plugged in. And I've seen situations when you, for example, used standard header and they were placed close to each other. And then when you put there the plug is actually much bigger than the header, and they were not. It was not possible to plug them, or exactly as you say, two USBs, or this was like classic.
Or a very common stuff, a flipped display. So looking at the flat cable and the display that will be actually flipped. Or the other thing, when you are looking at the PCB on the screen, you can zoom. So everything looks big. You have a lot of space in between. And then when you print it out and the board is like this, okay, so that comes as a surprise, always. Yeah, now that we've covered what we can do to make a product not to fail, there are other things that can make our products fail. So we need to think about the failure modes. And thinking about them early is less expensive than thinking about them later on in the phase. So if we implement countermeasures early in the design phase, that's much cheaper, or in the requirements, that's much cheaper than once we go to production. Maybe it's even impossible. So the good technique for this is the DFMEA. This can be a separate workshop for that. So just scratch the surface, think about the modules on the design, what can happen to take it out of the specification, what can happen to make it fail, and how that failure impacts the user. How often is it going to happen? Is there a risk? Is it going to happen once in a million times and that the device will just reset? Doesn't make sense to maybe implement countermeasures. But what if the product dies and it happens on every 1,000 devices? On every one, that is maybe something that will be a problem. So if you see, for example, typical thing would be thinking about the power supply, and we can have transient voltages going through our power network that can cause device to die. So what we need to do, we need to implement the countermeasures in front of that to eliminate these spikes, or to be able to handle that.
Oh, here I have story. I have story here. I know maybe some people may think like, oh, my board only freeze or reset once a month or something. It's fine. But I know, for example, there was a manufacturer which was using a board which exactly maybe frozen once a month or something. But when this happened, they had to, I think they were doing something with some colors or gases or something. They had to clean all the machines. They had to stop production for I don't know how many hours, clean all the machines, and then start it again. So even this kind of like, it only freezes, I don't know, like
Once a month.
it can cost a lot of money.
It can, yes. For industrial product, freezing once a month is a
Yeah.
disaster.
On
For a
airplane, you don't want any freezing.
you don't want it. For a consumer device, yeah, I can tolerate even if it freezes once a day, maybe. So it happens. So my phone freezes when my son drops it, and then I have to reset it for maybe 15, 20 times, and then it starts working very well again. But it's a misuse, dropping it on a wooden floor from 1 meter height. That's the specification that we go back.
But I wanted to mention this because I know, again, people who are starting with hardware design or with maybe product design, they create these products, and the product we already mentioned, product works on your table, product sometimes will freeze, and people at this stage of development, they will think it's normal. It's not normal. There is something wrong with your product, and you need to fix it.
Yeah, because if they have 1,000 units in the field, or even 100,000 units in the field, that's a very big issue.
Yeah. Okay, we can move to the next because we
Yeah.
only have like half an hour, I think.
Okay. So yeah, thinking about the countermeasures and implementing reliability early costs less than implementing it later. So here is a DFMEA example template. I already mentioned how it can be performed, and there is a tutorial, so we don't have to talk about it. Now that we have designed our product that follows the DFX principles and that we think about all the mechanical and we anticipated all the failure mode, it's time to make it as a prototype, make the production files, right? So couple of wise things for production files is to standardize the production files package, have it standardized, use checklists. There is always a stress and panic when engineers are releasing the files to production. It's a high risk that something is forgotten because, oh, did I remember to do this? It's panic. And I remember when I was doing the design and having a checklist is like freeing the mind from all these stress and confusing thoughts that are coming, and the output is standardized. And also standardized package naming, which sounds ridiculous, but you never know if you are ordering something from your manufacturer, what kind of system they have in-house. They may go to email and they look at temperature logger for ARS, and then they dig the version from 5 years ago, and you order 3,000 units, so you get the product which is not the version that you wanted. And so it's important to specify the versioning and that all the information is there. If they have to ask questions, then probably the documentation is not so good. Everything should be clear when they see it. I have a colleague, he was working in one company and he had to take a laptop to the beach on his holiday. If the manufacturer in China sends a question so that he can reply to them, so it's obvious that maybe there was something wrong with those production files or with the management that they didn't do the proper handover to he was not the only engineer. There were 7 other hardware engineers in the team, and he was the only one taking laptop to the beach at the time. So it's like something wrong. I mean, your colleagues should be it should be documented. Everything should be clear. But also when ordering, as I said, you never know what kind of system they have. So one of our clients he wanted to procure parts by himself. It was a startup, single guy, founder. So he was looking to save money and he sent a request to the manufacturer. And it was not a Mickey Mouse manufacturer, it was a company with a US branch that they were sourcing from Taiwan. So he sent them, I want 1,000 pieces of this PCB. And what he got was 1,000 pieces of that PCB. But the problem is that in the production files, it was clearly stated that it should be panelized. Okay. And we had the design of the panel. But he said, I want 1,000 pieces of the PCB. He didn't say, I want them on the panel. He said, I want 1,000 PCB pieces. So they gave him 1,000 pieces. And the problem was that the PCB is very small. It was rigid flex. It was not possible to assemble it without some custom fixtures or without a panel. And that was like one piece was what $3.9, so that's like $4,000 trashed just with a simple inquiry that was not so specific. And he couldn't complain because they told him, but yes, you wrote you want 1,000 pieces. You didn't tell us you want them on a panel. So you never know what kind of system they have over there. So it's very important that everything is documented in details. Sometimes they offer like a short lead time and they ask just stupid questions to get time. So, oh yeah, the 4 days lead time starts now once we got all the answers. Like, oh, is this I don't know, is this a squared shape? So yeah, we've seen that also happens. Now, when we are talking about a manufacturer selection criteria, size matters, even if they taught us that size doesn't matter, it matters in this case. So we won't talk much about it, but these are criteria that you can verify that you can select a manufacturing partner. So the technical, can they do the PCB assembly? Can they do testing, programming? Can they offer enclosure assembly, box packaging? You can check if they can give you credit terms. So, for example, some of the clients, to manage the cash flow, they have a manufacturing partner who purchase the components. He keeps them on stock, and then they can pool. Like, I want to pool 300 units now, 1,000 units, but the manufacturer is keeping the components in stock for them so that they don't have additional lead times and
Yeah.
so on and cost. One interesting story about the cost transparency. There are manufacturers that are offering bulk prices and they don't want to give a cost breakdown of the product. I don't like that because then if you want to optimize something, you don't know what the actual cost drivers are. So, real story, a client of ours, did their own design and they were producing somewhere in Asia and they were paying like 50 euros or $50 per board. So they came to us and asking us, can you please do a redesign of this board because it costs us too much in production? So I asked them, okay, do you know what is the cost structure? Said, no, we don't know. And it took them quite a long time to get the cost breakdown from the manufacturer. It turns out that the board actually itself costed $30 and the other part was 21 actually. So 29 and 21. So $21 for the assembly. That was insane. Like, and it was a simple board. So we looked at if there's something like the tests are taking long, or the assembly is complex, or the flashing procedure is manual, or what is the reason that it costs nearly double. It turns out they could charge them so much, so they did.
They could, so they did.
So they did, yeah. So they did, and that was in Asia. So people think, yeah, we'll go to Asia because it's lower cost, but it's not necessarily that way. So it's important to have the cost breakdown and to be able to optimize later on and see what are the cost drivers. Otherwise, you don't. How can you know what's the reason of the cost? How to optimize it later on in production? So for me, that is like a red flag in that sense. And also the size of business. So one of our clients went to China to produce as a startup. Everybody was telling him, don't do that. Start, build locally, learn, and then go to over there. But we can talk about this. There is a topic. So he went to a company that has a revenue of $300 million, start producing his device, and he had like volumes of few thousand units at the beginning. So it's not an interesting business for them. He was like something that they don't want to bother with that. And so ideally you want to be within top 20 of sales revenue with your manufacturing partner, right?
So how
Okay,
did
so
they? How did this end up? He ended up paying a lot.
this end up as a horror story actually. So he was not happy with them. They had a lot of quality issues because the operators were changing. So they trained the operators, they had the processes, but they trained them, but then they pick new ones. So there was a high fluctuation on the production line. So they had a lot of quality issues. So he hired a German guy to be there to monitor that, but it was still a nightmare. They were also doing it at the third shift at night because it was not interesting for them as a business, right? They were focused on high volume manufacturing. So he found a new partner, a new company, a smaller one. So he moved there. But what was the problem? That he didn't continue manufacturing here. He stopped the manufacturing there and moved here instead of doing it in parallel. And what happened is that it took them a year to set up the production. It took them a year. So basically, he lost 1 year of revenue due to that transition. But that's a common misconception where people think, yeah, I will go to Asia and I will produce there. We'll talk about that in some of the next slides.
Yeah, actually, many companies they make PCBs in Asia, but they do assembly close to their company, because if there are problems, and there are often problems during assembly, they can go there and they can talk.
Exactly. So proximity to R&D is also one of the parameters when selecting the manufacturer.
PCB, I think PCB can be manufactured in Asia. That's no problem.
But the assembly is an issue. So when I was talking about the PCB, I was thinking about more the PCBA, the whole assembled. So now that we've completed our production files and selected the perfect manufacturing partner, now we can build a prototype unit. And what we are doing in this phase is that we will do the PCB assembly, but while waiting for the PCB to get assembled, we can use that time smartly to prepare test plans and plan for the verification of the board. Here is one example with these circles, where in the documentation, the breakout of the panel, it was placed, it was marked where it should be and how, but the manufacturer just ignored it. So they positioned it on where they wanted. And basically this caused a mechanical issue when fitting inside the enclosure. So it's very important that in the documentation there is even like how to break out the panel. So it's a tiny detail that can, the board works perfectly, but we just have to scrub it off inside the enclosure. So it's an issue. So in the prototype phase, once we get the board assembled, we also need to get the first DFM feedback. Was it easy? Was the documentation clear for the manufacturer? Did they have any questions? If they had questions, it's important to put it into documentation for the future revisions so that we don't get the same questions again. Did they have any issues? Did they have to rework the board? Maybe a rework is a sign that some footprint is not good or that the component is sliding off. So also asking them what was difficult, can they suggest something for future revisions? What would be easier if we modify the design, so on. So it is like the first DFM, design for manufacturing feedback, and it should be taken seriously so that it doesn't repeat in the next iteration. And as I mentioned, while we are waiting for the prototype to arrive, we can use that time in a smart way to prepare the verification plan and also work with our firmware engineer to prepare us the test firmware. So this is an example. I didn't put the whole document, just a screenshot, otherwise it would take a long time. Make a plan how the board will be verified, what are the acceptance criteria, what are the expected values, and what are the actual values on the boards.
We need this document anyway, because and ideally we would like to have maybe this document for every single board, and put the values and measurements so we can actually see the behavior of every board what we receive.
Exactly. I had a discussion with engineers that this doesn't make sense. If I square C is working, it's working. If the board is working, it's working. So why would I spend time doing that? Yes, but the reason is that it may work now, but it may fail in the field if the temperature changes, or we have tolerance in the components, or maybe your power supply is working but has a high ripple, or it's dropping when the Wi-Fi module is trying to connect, or a GSM module is trying to connect. So it's important to document that. And also, if we are working for a client, how do we tell him, yeah, we've tested your board and everything is fine? Yes, that's
Yeah.
good.
But
Yeah, we've spent.
especially even for these very first boards,
Mhm,
assembly house, when they are creating these low volume productions, very often they have to do it kind of manually.
mhm,
So there can be some mistakes, and you may have random behavior in these prototype boards because there still may be some problems which you need to
mhm.
fix. And three boards may work perfectly fine, and fourth board may not work. I square C may not work, for
May
example.
not work. Yeah, yeah, exactly. We had one project that was long time ago where the devices work, but very rarely it happens that it doesn't work, and it was specifically the I square C. And the reason was the tolerance of the capacitor, because that device used also the power supply to insert the communication through the power supply. And in some cases, if the capacitor tolerance was not good, you know, if the capacitance changes, then there is no power supply for the rest of the circuit, so the
Hmm.
circuit fails. But that was happening
Only
in
on some boards.
not on only on some samples. So it's good.
Mm,
These kind of tests detect those issues. So something is on the edge,
yeah,
right?
and
Or as you said,
it's always. I can say like almost always.
yeah.
Not for simple boards, for more complicated boards, there is always some kind of problem on
Yeah, yeah.
some board.
So also at the temperature,
Mm-hmm.
maybe the board is working, but when you put it inside the enclosure and you put it um, inside the temperature chamber, it gets hot or it fails. So this is also critical to check. So now that we tested our prototype, we verified it, it's good. We didn't make any electrical mistake, we didn't make any mechanical mistake. If we did, we would have to make the design update. And once we, let's say we made the mistake, let's try not to, let's be honest, we
Let's
made a
be
mistake.
realistic.
So we'll be realistic. We made a mistake, but we fixed it now, and now we can go to the validation phase to validate our product. And what happens in the validation phase? Yeah, so it's getting close to the market. So now okay, I had one slide in between. So in the validation phase, we are validating if we are actually building the right product and if the product is built right. So we need to validate it against the initial requirements to link our test cases to the requirements from the beginning. So if we didn't have the requirements, we technically cannot fail, right? And this is done by the QA team and also beta users and friendly users, so that the feedback from them is implemented back inside uh, in the design update if they need it. And also in the validation, we can do this highly accelerated live tests and stress screening that that is used to uncover product deficiencies and common failure modes. Sometimes in order to save time and accelerate to market, people decide to skip certain steps. So this is like taking risks. So there's a fine line between calculated risk and doing something crazy. I have an example, a client who skipped the temperature tests. It would be a simple test just to test the product within the specified temperature range, and he wanted to go faster to the market to ship it. And what happens? So in sunny California, when there is a nice hot weather, the diode starts leaking in the opposite direction at the higher temperature, and that cause the performance of the product like the user is holding a button. Okay, so the products were blocked like the user is holding the button permanently. Like this was the issue because they didn't do the simple temperature test that would last maybe half a day, not even so much. Just put it in the chamber and see. They didn't want to do that. Don't spend money on that. We don't want to move fast, break things, right?
This is how you
But
learn.
this is how you learn. But luckily, it was a first series of few hundred units, so it was okay. Yeah, no, users were not so angry about that. Yeah.
Not everyone lives in
Not,
California.
yeah. So yeah, we won't talk about this. This is a separate topic, but we can do the temperature, the common tests like temperature cycling, humidity, aging, mechanical cycling. So types of acceleration, we can usage rate acceleration. So for example, if our product has a button that will be pressed 1000 times during the life cycle, we can simulate that in a very quick way and we see if the product survives or if the button breaks, or we have a cable that is being plugged or unplugged 1000 times. So we can simulate that to simulate the whole life of the product, right? So these types of tests are necessary to verify that the product is reliable enough. You don't want to have products that are breaking and at 30% of their life cycle, causing returns. So the highly accelerated stress screening is happening slightly above the product specification, but not being over destructive limits, So this is finding the mechanisms that would not actually be happening in real life, but stressing the beyond real life scenario just to make sure the product is reliable.
Yeah, because then you will find the
You will
weakest
find
places.
weak spots. Yes,
Yeah.
exactly. Yeah, because uh, we hardware engineers think that the PCB is the most important part of the product, but actually the product can fail because of the simple plastic clip or any other component that's not related to the PCB. And failure is a failure still. Yeah. So these are just a list of example of the environmental tests. This is actually required for compliance for a class 1 medical product, just to show if somebody didn't have experience to get in touch with that. These are the type of tests that are required for compliance. Some products some standards don't require that, like for consumer products, it's optional. Yeah. And here is the example of the test that we did in the development phase and what kind of issues that we uncovered. So we did the tests in the chamber. So for example, simple tests showed that the alarm is not triggering on the temperatures below -5, which was very critical for product because the product will be sold in the Nordics when temperature can go even below that, much below that. The issue was
Buzzer,
in the
yeah, I've seen this.
yeah, but not only buzzer, it was the whole buzzer circuit. Due to the lower temperature, the capacitance is reduced. So the boost converter was not able to start and trigger the buzzer actually. And this has been solved by adding additional capacitance. But also we found issues also that the buzzer was failing, the corrosion, the mechanical issues on the product, like the LED peeling off and so on, heavy oxidation. So this is something that had been detected by the environmental tests. And what would happen if the product went to the field? This would be a very expensive issue to find and to reproduce. And so doing like these tests upfront is actually cheaper for the client than launching the product to save time and save some money or not doing that. So in the validation phase now, when we validated that it's great and it's reliable, and now we have to do the compliance test. So this is just a brief what needs to be done for the compliance, and you already have a separate webinar for that. So it's best to refer to that one. And now we can, oh yeah. So now we can start introducing our product to production, the new product introduction, right? Yeah. So it's certified, and now we can. Actually, this can happen in many things can happen in parallel. So you can start preparing the processes for production line, and in parallel doing the compliance tests and so on. Because if the test points what will not move, if the test firmware is familiar, we already know how it will work. We know how the board will be tested, so this can be prepared actually in parallel. But you cannot sell legally. It doesn't make sense if you produce product and then they fail the compliance. So we can start setting up the processes while this is happening in parallel, the validation. So what we need to do here is actually setting up the processes, give all the documentation to the manufacturer that they need. Because imagine somebody in a production line, he gets a PCB, components, and they need to assemble it. They need to verify it that it works. They need to ship it later on. So one example is what I've heard. So how do you test the product? How do you know it works after the assembly? So we turn it on. If it blinks, it means it works. So we pack it, and it can go. It's a real example. So that's one strategy. But the other strategy is to prepare the instructions for your manufacturer how to actually test the board. So make the test plans. What does it mean that the product pass or fail? What are the criteria? Prepare the assembly manuals. So how do you assemble electronics and mechanics inside? So if your manufacturing partner is building a test fixture, he will need the Gerber files with the description of test points, the mechanical data. They will need also instructions how to build the firmware flashing tools, or if you are building that, you need to give them instructions how to use them, because they will not know. Also, for IoT products, they need to be provisioned to the cloud during manufacturing. So secure chain of trust. How do you generate the unique certificates and connect them to the cloud and then flash them into firmware during the production? This has to be implemented also. Another aspect very important is the traceability. So each product will have a serial number. So once it's tested, you'll get the serial number, it will get a label printed, the serial number will be flashed inside the device. An interesting story how we failed 10 years ago for Apple MFI certification. So they've sent, if you want to pass the MFI, it's a long process. I won't talk about that, but one part of the process is sending the actual devices to Apple so that they test it and that they verify it. So 2 samples, and they connected to the devices, and they've seen, because it was a prototype device from production, so it had some random serial number on the enclosure, and that serial number didn't match the serial number in the firmware. So they rejected us just for that simple reason, because the serial number did not match. And it was a prototype. Like, okay, yeah, it has to, it's a tiny detail. It was a prototype, but still it was important for them for the certification, right? So we have to repeat the whole process for, not the whole part of the process, because the other part of the process was including sniffing the communication with all the Apple devices that the device will be certified for, that you want to put on the enclosure. Certified for Apple, iPad Pro, iPhone, blah, 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 all the devices that. So you need to sniff the communication with a special device and upload logs of the communication to Apple. Like,
I would
very
like to point out maybe what some people may not realize if this testing is not done by the manufacturer, and if you receive all the boards directly from production and you find there is a mistake or problem or something, or you have to test it and there will be some boards which are wrong, it's going to cost a lot of money to fix these problems. So that's why it's much better to have all these tests directly in production. So before they press the button and start generating thousands and thousands of boards, they will make a batch, they will test it, they will be sure everything is okay, and then they will start the production. And also, they test all the boards, because on some of the boards there may be short circuit or something. They will find the problem, they will fix it.
Exactly, yeah. Fixing it on spot. And this is also good when evaluating the manufacturing partner if they have an engineering capabilities inside. Many of them have just the technicians, and doing the root cause analysis can be a problem. So it can happen that if they have an issue technical, that it comes to the design, if they don't have an engineer who can understand the actual schematics beyond, oh, I understand, oh, this is a transistor,
Yeah.
right? So somebody who can understand how it works. So this is the couple of screenshots how the documentation should look like. So it should be very clean, and that the manufacturer should have all the information so that they don't wander around and make guesses. Every test point marked, every mechanical drawing, instructions how to test, how the specification for the testing, how they should program it, and so on, so that they have all the information needed so that they can start producing. So this is the first phase of setting up the processes, and it's very important to count that there will be failures also at this point. Sometimes it will be due to the process, and sometimes it will be due to the board or the design or something. So it's like setting up and planning for that time. It's not something, yeah, here's the documentation and it will work magically. They have to also learn about the product and learn how to. And now that we set up our perfect processes and the manufacturer learned how to make it, and they have a great engineers and technicians, and they don't have a churn of people at the production line. So they all learned. Now we are going to the mass production of our product. So we are finally ready. So congratulations, Robert. You did a great job on everything
Now we
from
can
the
press the
requirements.
button.
We can
And
now press the button, and now we can just count the money, and that's it. That's it. We did our job. Now, in this phase, so this covers everything from the manufacturing process improvement to the ongoing cost reduction, but there is still work in it. So, and the main goals, so there will still be like these early infant mortality issues. We want to eliminate them, and this we need to do the sampling of the product. So it will be functionally tested, but we also want to do the reliability test. And when selecting the manufacturing partner, it's important to see if they have this kind of capabilities. So what happens when you scale production? You get the new issues that you didn't have previously with your 100 units. So now when you have 10,000 units, you will have 10 devices with some issues that happens only once in 1,000 produced units. So that can take a long time to find the root cause actually why this is happening. So this is not a failure. It should be planned for that. But this kind of low defect rates that happens that you don't get at the lower volume, this will start happening now, and what can we do about that? So we need to collect feedback, right? And develop systematic process for collection of the feedback. So your client can just send you a voice message on Viber, can send you another issue on email, put some description on Dropbox, and so yeah.
I know exactly what you mean because, again, when I was starting with hardware design, I received this kind of feedback like, this is failing, we need to fix it in the next revision. And I was like, oh, yeah, okay, I will remember. You will not remember. Because it may take even like 1 year, for example, to maybe produce new version of the board or something. You need to collect everything. You need to document everything.
Exactly. And sometimes we have discussions like, oh, we don't have time to do that with a lot of effort. We are too busy with other stuff. So just say, okay, so we will just design it the same next time because we don't know what the issues are, and your manufacturing partner will produce it with the same, so we will have the same issues. If this is okay for you, then it is okay for us. I mean, if you want the same design with the same issues, yeah, that's a good thing. So what can we do about that? So it's important to collect the feedback. And as you said, it may pass 1 year and you won't remember the voice message on Viber and you won't remember the email with it doesn't work. So this is there should be a systematic process of how to collect that, who's doing that, and a simple Excel spreadsheet can help, and then we can decide how to do the root cause analysis. And what good idea is to once it is systematically collected and it's in one place, you can do the root cause analysis, and it follows the Pareto's law. So basically 80% of the issues will be caused by 20% of the root causes, and focusing on fixing those first would be the best investment. And then maybe later some non-critical, and deciding if can we live with that or we need to fix it. Is it critical? So this is like having a feedback collection and having it in a systematic way. So an example, just a simple table. Date issue reported, describe the issue, how critical it is, and then what can we do about that. So once we've stabilized the production now, and we eliminated the early mortality issues and those weird issues, and the processes are fine, now we want to improve the throughput. We want to produce more. So instead of one button, I want to press 3 buttons so that I have 3 production lines running and producing our product. So what can we do about? So one thing is that, yeah, we can make it parallel. That's one thing. The other is optimizing time on the assembly. It means maybe reducing time on testing, flashing, reducing the complexity. At the beginning, an example, we planned implemented some complex long tests, and over time we see that some of the tests don't make sense. So we can short them. So for example, for an audio product, there was like a no sound test, pink noise, white noise, and duration was long, and then testing each individual microphone and so on. So we decided just to focus on no sound test and the sinus wave, and that was good enough to give the results and shortening the time of the test. So instead of 90 seconds, the test was reduced to 20 seconds. So when you calculate that to tens of
Thousands of,
thousands of
yeah.
units, yeah, you get the calculation in terms of the money and the time and the ability to increase the throughput in production. So yes, it's good to get the feedback also from the production line, what doesn't make sense for them, what takes long time. So yeah, there are ways to.
Especially after
optimize it.
you manufactured 1,000 pieces, you get idea like,
You get,
okay, it looks like with this there is no problem. I just need to know it works or it doesn't work.
yeah, exactly. And now that we want to scale at production, now it's a location strategy. Robert, shall we move to Asia now? Do you think we have enough volume to move to Asia? I don't know. Product is good, is reliable. People are buying it like crazy. So, do you know a good manufacturing partner in Asia so they can do the job for us? So this is not a one size fits all. And as I've mentioned, it's always best to start locally because the proximity to R&D can be critical. If you are starting to learn how to build a product, implementing the processes, and you are somewhere in Asia and your team has to travel, well, that's not the time zone difference, the language barrier. So
You
that's
know,
not
you
a
exactly name all of them. Because people may forget time zone difference. It means 1 minute, one email a day. Like very
Mhm.
often, you send one email, you receive one email, and that's it. That's the end of communication. Language barrier, huge, huge problem
Exactly.
sometimes.
Exactly. Yeah. So this is, how to consider and when to consider the location strategy. And if the volume is low, it doesn't make sense. So, for example, we in some projects, when we analyze the costs, it was 10% more expensive to do it in Europe, in Eastern Europe, compared to China. But you don't have time zone difference. You don't have long lead time due to the shipping. You don't have this language barrier. The engineers can travel there in a couple of hours. So the customs and all these trade wars and the insecurity about that. So when it is 10% different on the assembled board, but on the overall logistics and everything that if we go back to the product value equation, it, it may not be lower cost there. Yeah. So there are hidden costs of going offshore, like I've mentioned. Yeah. Also the impact of the inventory in transit. So imagine you have uh, 300,000 euros in board traveling 6 weeks, 8 weeks or something.
And maybe lost.
Customs, maybe law. Hope not. Did that happen?
Mm, not really, but I know a friend of mine. Sometimes he actually travels by himself because if you have, I don't know, processors which are very expensive,
Mhm.
uh, you really don't want to lose these packages. It's cheaper to just go and travel by car than shipping this by UPS and then receiving email like we dropped your package. Like what?
Yeah, not a good stuff. Yes, there is also a business model mismatch. Yeah, so in Asia, they are big manufacturers focus on high volume and starting a new product or especially a startup. There will be smaller volumes, frequent changes. So this is not a business for them that is interesting. So they may cancel the cooperation. So imagine you start with the manufacturer and they get too bored with your changes and small volumes and doesn't make sense for them to set up a production line for 800 units. So that just doesn't make sense for them. So they may cancel the cooperation if they see that it's not profitable for them or that the startup is risky. I know stories from, especially from this crowdfunding. You see, they raised 500,000. Wow, but they are actually swimming in debt, so they cannot complete the product development. They spend all the money. They cannot complete the manufacturing and shipping. So it's a very risky business to take those kind of projects.
Hmm.
Some are good, but usually if they don't have external funding or other sources of revenue, it's a high risk that it will fail. Yeah.
Hmm.
No, yeah, we already discussed about this. Yeah, start locally, and then once you've learned how to build a product, then move to, and you have enough volume and you have a good manufacturing partner. So also the other approach, if you have a multinational contract manufacturer that has a local presence close to your R&D or somewhere, and that he can do the transition offshore with, in a smooth way, that's also a good thing, rather than doing it yourself and learning the harder way. Yeah, so now we can summarize now that we did the successful development and manufacturing and the client likes it. So now we can summarize all the mistakes that we did so that when we are developing our new product, we can make sure we don't repeat them. So I don't know why this is not. I had animation here. I don't know why this is showing first, but yeah. So the first one is lack of risk of lacking the risk of management risk risk management and thinking about the compliance in the later development phases. We spoke about involvement of the manufacturers late once. Yeah, we did the design and now we can find somebody who is going to manufacture it, and then not understanding their capabilities, and so we give them our design, they say, oh yes, Zoran, but sorry, we cannot do this stack up, and you have to move all these components further away from each other because our pick and place machine cannot fit, or your test points are too close to each other, we cannot make this kind of picture. So yeah, making assumptions about the technology without trying it, as you've said, taking several development kits, testing, doing the proof of concept to make early technical risks, identify them. We decided we will not skip any more validation steps because we don't want our product to fail in sunny California, right? And we will talk to our client next time so that we are sure that we understand their requirement, not just designing the product and finding out it's not what they actually wanted. And the team will collaborate. So our mechanical engineer will talk with a firmware engineer and the hardware engineer, and with your regulatory consultant will also support us on finding out what are the requirements. So yeah, and of course the manufacturing partner will now know how to pick the right one and with the right size as size matters.
And then there is last one, or which one is the other?
Last one.
This is the last one.
This is the last one. 86 out of 86. I didn't make 90 slides because it would be so I had to stop at 86. Just 90 would be too much. Yeah. Okay, so now this is now obvious. We went through all the 7 phases, and people now understand that if they don't make the requirements properly, then there's a problem with the validation. There's a problem with the many design changes, the delays with the projects. If the strategy is not correct, we cannot develop industrial product the same as consumer product. Go fast and then we'll fix it later. That approach doesn't work for those 2 industries the same way. Perfection, time to market over perfection is not for both of them the same. And yeah, we need to involve the manufacturing early. Yeah, so people can read the slides, so I don't need to repeat them. They got 86 slides. I missed the last one, like death by PowerPoint.
No. Does it exist? Something like this?
Yeah, I Googled a lot. There are a lot of memes like that by PowerPoint. There are a lot of funny things.
No. I think it was very interesting. I know it's is longer than what I think it's more than 2 hours, but only a
Yeah,
little bit
2 hours.
more. But we said everything important. So for anyone who exactly at the beginning you exactly explained who this presentation is good for people who it may be even like electrical engineers or someone who is really working already in companies, but they never seen the whole process. So it's very, very useful. I know you covered many details. Exactly as you said, some of these topics, they are like for another presentation, another video, but it's important to know about this. So that's why I'm very happy we covered everything. And I wanted to ask, so what do you do actually? So,
Oh yes, something about me. Yes. Um, that comes nice as a cherry on top after 86 slides.
so everyone who is still watching, they will be
Everyone who is still
interested.
watching, who's still watching, oh, the two poor guys that slept on the desk. Yeah, so in my previous life, I was a hardware engineer actually, and I was working on the development of security products in high volume and also development of the gambling machines later on. That was a completely different beast. So very low volume, but highly expensive machines, like 120,000 euros per system, and very low volume. So different approaches in the development, as I've mentioned earlier. And then I started my own company, so now I am a manager. And as a young guy, I hated managers. I thought they don't do any real work. We are the engineers. We run the world. Without us, there is nothing. So the fate punished me now to become a manager. So now I am more focused on managing the company and managing the processes. And we are a company of 25 people. So we are developing electronic products, helping clients do what we just spoke about, going from the idea to the manufacturable products for industrial tech companies, and but without doing countless design iterations and expensive recalls from the field by applying the 7 gates process, right?
Can you
So
open
this
your
is
company website so everyone knows if someone would like to contact you? You are
okay.
where you are based
We are based in Serbia.
because number of times you mention pounds. So I was curious if you work with UK
Pounds.
companies or.
Yeah, we have a lot of clients in the UK
Mhm.
and some in the US, but our main market is the DACH region, so Germany, Austria, and
I, but I don't
Switzerland.
see your website because maybe you need to
Yeah, I
share it.
have to share the screen. This is actually what we do. Some of our projects are in medical, security, industrial,
Oh, many
appliances,
projects.
professional, PCB design. Yeah, so different areas. And yeah,
Okay,
if they want to contact me, they can reach out to me on LinkedIn. I'll be
perfect.
happy to have a discussion if somebody wants to get into a discussion about any of these slides. Yeah,
And I
continue.
hope you will reuse this presentation because I'm sure you spend a lot of time to prepare this.
Yeah, I will reuse it definitely. I had a similar presentation when I was doing it at the university. That one was just like 6 slides, but I said Robert has a serious audience, so I have to give some value over
Multiply
there.
it by
I have
10.
to multiply, right? Well, 10 is a little bit underestimated, more like 15.
Okay,
I cut it a little bit,
okay. So thank you very much, Zoran, for this. And
yeah.
I really hope people will find this useful. And if they have any questions or something what they would like to add, they can leave questions.
I have one thing to add for you, Robert. So first, thank you for inviting me. It was a pleasure talking about it. I didn't have a feeling that I'm being recorded. So hopefully when I watch it, I will not say, oh. So the other thing I want to thank you for all the things that you did for the hardware community in the last, how many, 13 years, and all the videos and tutorials and everything that you've done. So that's a great thing, and keep doing that. I was
Thank you.
one of the early supporters back when you started. I bought your training courses, and we are buying that and using that when there is something new. So every new engineer that comes to our company, first thing he has to watch your courses, and then he can start working on something real.
Thank you. That's very nice to hear. Because actually I've seen in many slides what you mentioned. I was exactly thinking, oh, I made video about this, or I mentioned this in one of my courses. Like for example, when you were talking about the releasing the manufacturing documentation or going through the releasing process, I remember like I've done a number of videos on this because people think it's not important. It's so important. Like you must have release procedure. Even if you hate procedures, if you hate paperwork, this is one which you need to have because you will forget. You will forget something.
Exactly.
Okay.
That comes from the real life.
Yeah. So let's not make this longer. So thank you very much again, Zoran. And yeah, I'm very happy we could make this video. Thank you.
Thank you.
That's all for this video. I hope it was helpful. If you would like to learn more about electronics and board design, check out our online courses. You will find everything important there, from basic board design up to advanced board design and high-speed PCB layout. We have courses in Altium, Cadence, KeyCAD, and also courses covering many different topics, for example, FPGA, EMC measurements, and so on. Visit our website at fedevel.com. That's all for this video. Thank you very much for watching, and don't forget to leave your comments. See you in the next video. Bye.